So what if we have group data? So what if I give you a frequency distribution instead of the raw data itself? So if we have a frequency distribution, we can approximate our standard deviation as the square root of, notice it's still the sum of our deviations squared, right? But we're also multiplying by the frequency and then dividing by n minus 1. So if you have the classes given to you and not the raw data values, right, we're going to estimate mean and standard deviation using the midpoints to represent our x values. So these x values here would be your midpoints. So we pretty much use class midpoints for calculations and then boundaries to graph. All right, so just like in the last section when we talked about the sample mean for a frequency distribution, right? The only difference is we're now multiplying by the frequency of that class to account for that repeated addition, right? So we're not having to sit there and list out every single data value, however many times it shows up, and add it in. All right, so let's look at an example. So here we've got the raw data, but we're going to collect our random sample of the number of children per household in a region. And so we want to find the sample mean, sample standard deviation for this data set. So first thing we would do, right, is we would group this data together because that's a lot of data, right? It wouldn't make sense for us to sit here and do it 1 minus mean, 3 minus mean, 1 minus mean, 1 minus mean over and over and over again, right? For all 50 of these families, would it? That's going to take a long time, be way more tedious than you would need to do. So instead, what we would do is we would build a frequency distribution. And in this case, it wouldn't make much sense to put it into classes, right? Because we know what the individual values are, right? So we wouldn't want to group. You could put it into classes, so we could do 6 minus 0 divided by however many classes you wanted, right? But that wouldn't make a whole lot of sense since it's such a small grouping of numbers. So I would actually go in and just get a frequency of the individual data values themselves. So how many times does 0 show up? How many times does 1 show up? And so on. So if we do that, 0 shows up 10 times, 1 shows up 19 times, 2 children shows up 7 times, 3 children shows up 7 times, 4 children show up 2 times, 5 children show up 1 time, 6 children show up 4 times, right? And so we need our sum of our frequencies. All right, so if we add up the sum of those frequencies, right, what do we get? $50, right? And we should get 50 because we knew there were 50 households, right? So from there, the next thing we want to do is we want to multiply the data values times the frequencies, right? So thinking back to how we found our sample mean, right? So the sample mean, remember, would be it's basically your weighted average, right? Where frequency is your weights. So it's the sum of x times f divided by the sum of f, right? And that was in the last section, but I don't think we actually did an example with it then because it's coming back now. So we want to find all of those data values times the frequency, right? So 0 times 10 is 0. 1 times 19 is 19. 2 times 7 is 14. 3 times 7 is 21, right? 4 times 2 is 8. 5 times 1 is 5. 6 times 4 is 24. And so we need the sum of that column. And again, I will give you this table layout if I put this on the test, right? I'll give you the table layout and the formulas for group data. So you don't have to remember that. So it's 91. So then our sample mean, right, is going to be 91 divided by 50, which is approximately 1.8. All right, still with me. So essentially you can think of this as you're just doing a weighted average, right? So your frequencies are your weights. So then this is really X times W, right? If you kind of think about it in terms of doing a weighted average, your frequencies are your weights. So from here, now we kind of get into that standard deviation routine, right? So we want to kind of think about it as, okay, we're going to do the same kind of process that we would do for standard deviation normally, right? So if we're normally finding standard deviation, what are we going to do? We're going to subtract the data value from the mean, right? Or sorry, the mean from the data value. So X minus X bar, right? So here that's going to be 0 minus 1.8. 1 minus 1.8. And all the way down when we do that. So 0 minus 1.8 gives us negative 1.8. 1 minus 1.8 gives us negative 0.8. I used 1.82 when I did the calculations, so I'll just add that extra decimal place there. It's always better to have more decimal places than not enough, right? So then 2 gives us negative 0.18. 3 gives us negative 1.18. Sorry, positives. These are positive ones. 2.18, 3.18, 4.18. All right, still with me? And then kind of going in that same process for standard deviation, right? We want to square our deviations, right? So this part's all the same as what we were just doing with the raw data, right? So negative 1.82 squared gives us 3.3124. Negative 0.82 squared gives us 0.6724. And then we keep on going down that route, right? So 0.18 squared gives us 0.0324. And then we get 1.3294. 4.7524. 10.1124. And 17.4724. Normally, if this were the raw data, right, we would add up at this point, right? But does it make sense to add at this point? Not really, right? Because right now we're only counting each data value once. We're not accounting for the fact that they show up multiple times, right? So we want to multiply by their frequencies. So we want to multiply the deviation, X minus X bar squared, times the frequency that it shows up as. So doing that repeated addition, essentially. Right? So we're going to multiply the 3.3124 times our frequency of 10. We're going to multiply 0.6724 times its frequency of 19. And so on all the way down. So if we do that, that gives us 33.124, 12.7756, 0.2268, 9.7468, 9.5048, 10.1124, and 69.8896. And so now we're taking into account how many times each of these deviations squared occur. So we can add those up, and that's going to be our sum of squares. So if we add up this last column, that is our sum of squares for this, which is 145.38. All right, still with me?
Did you add all of those up?
Yep, so I just added up the 33.124, 12.7756, all of those numbers in this last column to get this, yes. And then that's our sum of squares. So it's really adding in one extra step to finding the standard deviation, right? In that we have to account for how many data values we have. And so from here, now we're just back in the normal process, right? So s squared is going to be the square root of our sum of squares, 145.38, divided, or sorry, s is the square root if we just go straight to standard deviation. Square root of 145.38 divided by n minus 1, we had 50, so we're going to use 49, right? And so we do that. When we do that, we end up with 1.7. All right. Questions? Yeah.
When we do that, do you want us to do this?
Well, in this, it's going to depend, just like before, it's going to depend on if you're looking at a sample or population. Because we're going to look at this again when we get to chapter 5, I think it is, in terms of a population. But for now, this one was specifically, it said it was a sample. So that's why we used S instead. All right. Other questions? All right, so let's say we have to estimate. So in this case, this one gave us the exact sample mean and standard deviation, right? Because we just used the raw data values themselves. We didn't use midpoints. But if we have a frequency distribution where we need to use midpoints, so something like this, right? I've got a figure here that gives us a survey of where 1,000 adults were asked how much they spend in preparation for personal travel each year. And so we have to make a frequency table for this data and then estimate the sample mean and standard deviation, right? So in this case, we don't have the raw data values, right? We have the classes themselves. So we have $100 to $199, $200 to $299, right? So because we don't have those raw data values, that's where we would have to use midpoints to estimate this instead. Right now, since the high end of it here, right? So it says $500 or more, right? We can just kind of, since the rest of these are set for hundreds, we can just say, okay, we're going to use 599.5 to represent the midpoint there. All right. But then you would do the same kind of idea. So if we set our classes up, right? So we'd have the first class going off of that graph, right? So less than $100. So that's 0 to 100, right? Or 0 to 99 since it's less than $100, right? And then 100 to 199. And then 200 to 299. $300 to $399. 400 to 499, and then we had our class of 500 plus, right? So when we calculate those midpoints, I'm going to call those midpoints X here. So I'm going to call the class midpoints X because we're really going to use those as our data values, right? So who remembers how do we calculate a class midpoint? Add them up, divide by 2, right? So 0 plus 99 divided by 2 gives us the midpoint of 49.5. Then here's the beauty, right? If we know our class width, do we have to keep adding up, dividing by 2? No, because we know that class width, right? So what's our class width? 100, right? So we can just add our class width to that, right? So we can go from 49.5 to 149.5. Then 249.5, 349.5, 449.5. And then here, we're going to use 599.5 just because of the fact we don't know where this class stops at, right? So we're going to go a little bit higher than we normally would. I would not give you one like that on the test where you have to kind of guess at what that last one should be. I would make it very clear. I would give you, most likely I would give you, if I did this, I would give you the frequency table already made with the midpoints on it so that you don't have to do that, because that's not what I'm trying to test you on this, right? But then from there, you basically do the exact same idea, right? So we get our frequencies, which are on that picture, right? So 380 adults responded they spent less than $100 before they travel, right? So we just pull those frequencies off of the picture. So we have 380, 230, 210, 50, 60, and 70. So our sum of frequencies should be 1,000. We knew we surveyed 1,000 adults, and if you add all those up, we do get 1,000. But then from here, it's really the same process, right? So you would do the data value times the frequency. You would add those up. I'm not going to go all the way through this one. I'll put the full slide up on Moodle so you can see it. But it's the same exact process as what we just did on the last slide, right? So multiply midpoint by frequency. That's going to give us this column, right? Add them up, divide by our sum of our frequencies, right? So X bar, in this case, the sum of our data value times frequencies ends up being 192,000. So then X bar is going to be 192,000 divided by 1,000, right? Which gives us 192 approximately. And keeping in mind, this is going to be an estimate of the sample mean, right? It's not going to be the exact sample mean because we don't have the raw data. But then same idea. So you do your data value minus the mean, data value minus mean squared. And data value minus mean squared times the frequency. And then add all those up to get your sum of squares, which in this case ends up being 25,668,750. Right, so our variance, our standard deviation then, is going to be approximately the square root of that divided by what? You tell me. Just n? 999, right? So n minus 1. So we end up getting a standard deviation of 160.3.